All right. I'm going to go over the Unit 6 Almost There quiz review. And even though the Almost There quiz is Wednesday, Thursday, remember, it's you get multiple attempts at it, and it's just going to go in as a regular classwork grade. That's going to be average with this. So just, don't worry too much about the quiz on Wednesday, Thursday. Think of it as a learning opportunity. All right, let's jump into the review here. This first question is kind of annoying. We got to create a Venn diagram where we have an event A where Gail, Alan, and Dante like scary movies. Event B where Alan, Tim, and Laura like comedy movies. And then we got Gina and Kelly who apparently don't like comedies or scary movies. That's weird. And let's see here. We need to label this. So we'll call this event A or this event B. And I'm just going to write in some names. So Alan, just, make sure we're aware, he likes both types of movies. So I'm going to put him in the middle. He falls into both categories. Then we got Gail and Dante who only like scary movies. They're in event A, all right here. And then we got Tim and Laura who only like comedies. What we do with these last two, Gina and Kelly, we're going to put them on the outside. So Gina, Kelly. Okay. So Gail, Dante, Alan, Tim, Laura, Gina, Kelly. Sorry, my handwriting is not great. So list the outcomes for the A union B. So A union B means all of the people in A and B. And so we have 5 people in A and B, or I guess I should say A or B. So Gail, Dante, Alan, Tim, and Laura, those are all people that are either in A or in B. So union, you don't have to be in both. You just need to be in one of those two. And there are 5 people that are either in A or in B, or in case of Alan, he's in both. So Gail, Dante, Alan, Tim, and Laura. Those are all the outcomes for A union B. The second question is A intersection B. So when it's sort of this upside down U, that's intersection, and you got to be in A and you got to be in B. There's only one person that fits that outcome, and that's going to be Alan. So that's our outcome there. List the outcomes for A prime. This is a complement. So it basically, and the complement is just saying, list all the outcomes for things that are not in A. So Gail, Dante, and Alan are all in A, and then you got Tim, Laura, Gina, and Kelly who are not in A. So those are the outcomes. Tim, Laura, Gina, and Kelly. Those are all the people that are not in A. The last 3 questions are actual probability questions, so find the probability of picking somebody in B. There are 3 people in B, not 2 people. There are 3 people in B, so it's going to be 3 out of something. How many people are there total? There are 1, 2, 3, 4, 5, 6. There are 7 people total in this sort of survey. 5 is kind of tricky. You're finding the complement of the probability of A union B. So basically, what you want to do is just find all the people that are not in the union of A and B and put that over our total amount of people. So it's still going to be out of 7. But basically, what is the probability of picking somebody that's not in the union of A and of A or B? And let's see here. So there are 5 people in the union, and there are 2 that are not. So it's going to be a 2 out of 7 chance of choosing somebody who is not in the union of A and B. Last one, find the probability of A intersection B. So basically, you got to be in A and you got to be in B, and there's only one person, so there's a 1 out of 7 chance for that. Okay. Let's get to the tables here. So we got this table. It needs us to fill in the totals, so let's just do that real quick. 4, 8, 2, that's going to be 14. 5, 3, 6, that's going to be 14. 2, 1, 9, that's going to be 12. For down here, 4, 5, and 2 goes to 11. 8, 3, and 1 goes to 12. And 2, 6, and 9 goes to 17. This number right here, you can either add up these or add up these. It looks like we're going to get 40. Okay. So we get to actually answer some questions now. Find the probability of picking somebody in the 11th grade. So there's a lot going on in this table. You got to kind of locate what you need. So this is our 11th grade people, and there are 14 people total in the 11th grade. So it's 14 out of how many people total? There are 40 people total in this sort of survey for class activities. So 14 out of 40. So find the probability of picking somebody that wants to do a dance. So here's the dance. There are 17 people total that want to do the dance out of 40. So there's a 17 out of 40 chance of picking somebody who wants to do the dance. Find the union of picking, of like the probability of picking somebody in 10th grade or wanting to do the dance. And so, you know, be careful here. There are 14 10th graders, and there are 17 people who want to go to the dance, but you don't just say 14 plus 17, because then we're counting these two people right here twice. We don't want to count them twice. So we want to sort of, you know, 4, 8, and 2. Those people are in 10th grade, and then 6 and 9. Those are more people that want to dance, but we don't want to count this 2 twice. So 4 plus 8 plus 2 plus 6 plus 9 is going to be 29, and that's still out of 40. And I'll just sort of write where that 29 came from. That was 4 plus 8 plus 2 plus 6 plus 9. So 10, find the probability of picking somebody that wants to go on a field trip and they are in 11th grade. So the union, you know, you got to be in both. And so here's our field trip. Here's our 11th grade. We have 3 people that want to go on a field trip and are in the 11th grade. So there's a 3 out of 40 chance of picking somebody that falls into both of those categories. This little line over the top, this is the same thing as doing that complement. So basically, what is the probability of not picking somebody that is in the 12th grade and also wants to do the talent show? So this is kind of confusing. What I would do is I might find without the complement first. So basically, how many people are in the 12th grade and are also wanting the talent show? So here's our 12th graders, here's our talent show, and there are 2 people that want both. So if you're asking for the complement, how many people do not fall into this? Well, there are 40 people total, and if 2 people want this, then just subtract 2 from 40, we get 38, and put it over our total amount of people. So there's a 38 out of 40 chance of picking somebody who is not in the 12th grade and also wants the talent show. I'll put this off to the side. We found that 38 by saying 40 minus 2. And then these last 2, these are those conditional probabilities. You just got to know how to read it. Find the probability of picking somebody in the 10th grade given that they want to do a field trip. So what you do with this, remember, we sort of set up a fraction. These are not going to be over 40. This second part right here, so how many people, you know, wanted a field trip? There are 12 people that wanted a field trip. So it's going to be out of 12. What is the chance of picking somebody who wanted a field trip and are in the 10th grade? There are 8 people in the 10th grade that wanted the field trip. So there's an 8 out of 12 chance of picking somebody in the 10th grade given that that person wanted a field trip. So this one, find the probability of picking somebody who wanted a talent show given that they're in the 10th grade. Okay, how many people are in the 10th grade? 14 people in the 10th grade. And out of those 14 people, how many wanted a talent show? 4 wanted the talent show. Okay. Let's keep going. 14, I don't remember ever talking about this, so we're going to learn it now. If you are given sort of choices like this, which of the following pair of events are independent? When they're written like this, probability A and probability of B are independent if, I'm going to give you a little rule, if the probability of A times the probability of B equals the probability of A intersection B. So we're given, you know, in each of these, so which of the following pair of events are independent, we're given 3 choices. And basically we just want to check, you know, if we take the P of A and we multiply it by the P of B, do we get whatever the number is for the intersection of A and B? So like, let's look at A, for example. On A, if I does 0.08 times 0.4, does that equal 0.12? So I can put that in my calculator real quick. I'm pretending like I'm doing that, and I get 0.032 if I do 0.08 times 0.4. Well, that does not equal 0.12, so A is out. Okay, what about B? If I take the P of A, so 0.30, and I multiply it by P of B, 0.15, does that equal 0.045? If I put that in the calculator, 0.3 times 0.15, that does go to 0.045. And so if P of A times P of B equals P of A intersection B, then they are independent. And so that's our answer here. C is not going to work. It's going to be like A, where they are not going to equal each other. All right, flip over. 15. We got a bag containing 3 red marbles and 4 green marbles. You draw one randomly, replace it, and randomly draw a second marble. What is the probability of the following events occurring? So, we have 7 balls total in this bag. What is the probability of picking the first ball that is red? Okay, there's a 3 out of 7 chance of picking a ball that is red the first time. There are 3 red balls. There are 7 balls total. So that 7 is coming from adding up all the types of balls in the bag. Okay, but it doesn't want just the probability of the first ball is red. It wants to know what is the probability of the events occurring. So that we pull a red ball and then we pull a second ball that is also red. Well, if we're replacing it, if we're putting the ball back in, there are still 3 red balls and there are still 7 balls total. And when you are finding the probability of 2 events occurring at the same time, this is when you multiply. If you were to multiply this out, you would get 9 over 49. On the quiz or on the almost there quiz, I'm just gonna write the answers like this, so you can, I just want to make sure y'all know how to set it up. I know some of us don't have nice calculators, and I want to make sure we can just set it up right. 16. This is a true story. I did not like the question, so I took it out. So skip. 17. Miss Kohler surveyed a bunch of people about their vehicles. Of those surveyed, 160 men and 85 women said they own a blue vehicle. If a person is chosen at random from those surveyed, what is the probability of choosing a woman or a person that does not own a blue vehicle? So, there's a lot of information here, but it's all in the table. So don't let this information in the problem throw you off. You're really just looking at the table. What is the probability of choosing a woman or a person that does not own a blue car? If you're doing this is basically finding the probability of a woman and the union of not blue car. That's what this basically is. So you find the probability of choosing a woman or a person that does not own a blue vehicle, not car. So just be careful here. When you do this, it's going to be out of 630. There's 630 people total. There are 200 women and there are 385 people that don't have blue vehicles, but you don't want to just add 200 and 385 because then you're counting this 115 twice. So what you want to do is you want to sort of add this, this, and this together. You want to add, the not blue men, not blue and women, and then the women together. And that will be your probability of choosing a woman or somebody that does not own a blue car. And if I add those up, it looks like we're going to get 470. So that is our probability right there. All right, and then let's see here, 18. The Venn diagram shows the number of people in a club. The diagram shows how many people like balloons, in the club, and how many people like cupcakes. And it's already, the numbers are here. So how many people are in the club total? You want to add up all your numbers for that. 24 plus 2 plus 16 plus 8. And it looks like we're going to get 50. So find the probability of choosing somebody that is in B, or that likes balloons. So it's going to be out of 50. There are 50 people. And how many people like balloons? Don't say 24 out of 50. You want to say 26 out of 50. There are 24 that only like balloons, but there are 2 that like balloons and cupcakes. So you want to add the 24 and the 2 together. That's how many people are in B. 20, find the intersection of B and C. So these are only the people that are both in B and in C. There are 2 people that like balloons and cupcakes. Who knew? There were so few people that liked both, and that's a 2 out of 50 chance. Find the probability of choosing someone in the union of B and C. So this is when you want to add up everything in B and C. They don't have to be in both. So there are 24, 2, and 16. You want to add up all those numbers. You're going to get 42. And then find the probability of the complement of B. So basically choosing somebody that's not in B. There are 16 people here that are not in B, and there are 8 people here that are not in B, so there's a 24 out of 50 chance of choosing somebody that's not in B. All right, we're almost done. 23 and 24. If you roll a single die, what is the probability of getting an odd number or getting a 4? You know, you could write out these possibilities. So this really should say single 6-sided die, but it just said single die. So we're going to assume 6-sided. 1, 2, 3, 4, 5, 6. What is the probability of getting an odd number or getting a 4? Well, there are 6 numbers here. So the chances of getting an odd number is a 3 out of 6 chance. And the chance of rolling a 4, we have a 1 out of 6 chance. If you find the probability of getting something or something else, this is when you add. So we want to say 3 over 6 plus 1 over 6, and we have a 4 out of 6 chance of rolling an odd number or a 4. And this makes sense. You know, if we look over here, you know, there are 1, 3, and 5, and 4. Well, that's 4 of the numbers out of the 6 possibilities, so that would make sense. There's a 4 out of 6 chance of rolling an odd number or getting a 4. The tricky part comes with something like 24, when the events are not mutually exclusive. So let's talk about this. So again, it's another 6-sided die. 1, 2, 3, 4, 5, and 6. And what is the probability of rolling an even number? Okay, there are 3 even numbers, 2, 4, and 6. So we have a 3 out of 6 chance of rolling an even number. Or rolling a 6. Okay, we have a 1 out of 6 chance of rolling a 6. But the tricky, I guess the tricky part here is this, that the 6 was an even number. And we don't want to count it twice. It's the same concept that we had back in 17. So what we were supposed to do back when we talked about this before spring break, whatever, you know, such a weird thing to say, was any sort of overlap. We wanted to subtract out the overlap. So we're going to subtract out 1 over 6, because there is one number that is both an even number and a 6, and that was 6. And if I do 3 over 6 plus 1 over 6 minus 1 over 6, we get 3 over 6. And again, though, I mean, if you just sort of, you know, if you write it out and just sort of look at it, my even numbers were 2, 4, and 6. And a 6, well, that's a 6. There are still only 3 choices out of the 6, and that's what we wanted to get. Okay. You know, I would keep this, you know, if you're able to print this out and have it, I would make sure you have this when you do the Almost There quiz. There's a lot of similar questions between the two. Good luck. Please email me if you have any questions. I miss all of you, and I hope you're doing okay and staying safe and healthy. All right. Have a good day.